Okay. Okay. Good morning, all. In last lecture, we have discussed about what is the effect of alloying elements on the steels, and in that we have first started with the classification of the alloying elements depending on their reaction with the carbon, and classification of the alloying elements depending on their effect on the critical temperature lines present in the iron carbon phase diagram. And after that we have discussed different uh, common effects caused by addition of the alloying elements on the we can say that iron carbon equilibrium diagram, or in the properties of the particular steel. Then after completing that, now in today's lecture we are going to discuss the classification of the steels on different bases. First, in that first classification, which I have written on the screen, you can see that classification of the plain carbon steel. Okay, in previous lecture we have already discussed that what is the meaning of plain carbon steel and what is the alloy steel. I will repeat that again. Generally, first, what is the steel? Steel is the alloy of the iron with the carbon, and here carbon will act as a alloying element and iron will be the base metal. And when there are only one alloying element in that particular alloy, suppose iron is the base metal and only carbon is present as the alloying element, other element may be present there, but they may be present in very small quantity, and they are present in the form of impurities. They are not added intentionally there. That type of steels will be termed as the plain carbon steels. And when other alloying elements are present along with the carbon, other alloying elements like chromium, nickel, manganese, silicon, aluminium, tungsten, like this number of elements may be there, then that type of the steels will be termed as the alloy steels. Now, generally in the steels, the percentage of the carbon uh, is starting from it, or it, you can say that it will be in the range from 0.008 to 2%. Okay, this will be steels. In some kind of steels, maximum quantity of carbon present is 2.3, whichever commercial steels are there, maximum percentage of the carbon in that steel is 2.3. Beyond that, that alloy will come in the category of the cast iron. Okay, that whichever classification is done, that I will show you in the next lecture in the iron carbon equilibrium diagram, how these steels are classified and how the cast irons are classified depending on the percentage of the carbon. Then here first only try to understand that whenever in the steel, that is the alloy of the iron and carbon, only carbon is present as alloying element, and other element may present but in very small quantity, and they will be considered as the impurities. That type of steels will be termed as the plain carbon steels. Now here, plain carbon steels are classified in three different types depending on the percentage of the carbon only. Uh, the first type is the low carbon steel, then medium carbon steel, and high carbon steel. In low carbon steel, percentage of the carbon is in the range 0.008% to 0.3%. In plain medium carbon steels, percentage will be from 0.3 to 0.6%, and in high carbon steel, percentage of the carbon will be from 0.6 to 2%. This is the basic classification of the plain carbon steel. Now, in examination, they may ask you the question, classify uh, or explain in brief classification of the plain carbon steel. In that, you have to mention that on which basis this classification is done, and what is the meaning of low carbon steel, what is the meaning of the medium carbon steels, and what is the meaning of the high carbon steel. Here, meaning is nothing but you can say that for low carbon steels, plain carbon steels containing carbon in the range 0.008 to 0.3%, that will be termed as low carbon steel. In the same way, medium carbon steel is plain carbon steel which contains carbon percentage in the range 0.3 to 0.6%, and high carbon steel will be plain carbon steels which are containing carbon within the range 0.6 to 2%, that will be termed as the high carbon steel. Now after defining what is the low carbon steel, medium carbon steel or high carbon steel, now you have to explain their properties, and after explaining the properties you have to mention some applications for each kind of the steels. Now how to remember the properties very easily, now I will tell you in the short. When these properties, now here only one alloying element is present, that is the carbon. Now carbon will decide the properties of that particular kind of the steel. Now you have to understand first what is the effect of the carbon. Whenever carbon is present in the low amount, then what will be the properties of that steel, and when percentage of the carbon increases, then what kind of properties or how that properties will get changed. If you understood that, then easily you can determine the properties of low carbon steel and medium carbon steel and high carbon steel also. Then first I will tell you, whenever carbon percentage is low, then at that time that particular kind of steel will be having very good machinability, weldability, and formability. Means you can do the machining of that kind of steel very easily. Whenever percentage of carbon is very less, then you can do the different fabrication processes or different joining or welding processes very easily. Or you can give means that material will be having very good formability, means you can give the different shapes. Suppose you can do the drawing, deep drawing of that material like that, means different processes you can do very easily, because whenever percentage of carbon is lesser, that kind of steel will be soft, malleable, and ductile in the nature. Low carbon steels, they will be soft. I will start with that. Means in low carbon steels, these will be soft, malleable, and ductile in nature. And due to that nature, you can do the whichever machining processes are there, welding processes are there, or forming processes are there, that processes you can perform very easily on these low carbon steel materials. And as you can say that as percentage of carbon goes on increasing, what will happen, their machinability will get decreased, then their weldability will get decreased, their formability will get decreased. Then what will increase now, as carbon percentage goes on increasing, their hardness, their strength, I can say that their tensile strength, their hardness, then their wear resistance, their corrosion resistance, their abrasion resistance, these properties will get improved as carbon percentage goes on increasing. Now we will see one by one. First, low carbon steel. As in the first line, I have mentioned that what is the low carbon steels. Plain carbon steel containing the carbon percentage 0.008 to 0.3%, that will be termed as low carbon steels. Now in the first, you have to write the properties. Now here, as percentage of carbon is very low, these are the soft, malleable, and ductile in the nature. Low carbon steels will be soft, malleable, ductile in nature. And in the second line, depending on the carbon percentage, you have to decide its properties. That is, it will be having excellent toughness, then machinability, weldability, and formability will be very good. Means different machining processes, joining processes you can do very easily on this material or these kind of the steels. Now the next point is regarding the hardening. Now, whenever percentage of the carbon is very less, it is very difficult to do the hardening on that particular material. If suppose carbon percentage is less and other alloying elements are also not present in that material, then you will be not able to do the hardening. Means you are going to improve the hardness of that material by conducting some heat treatment processes. Now, this is not possible as here, as this is the plain carbon steel, other alloying elements are completely absent here. And as it is low carbon steel, carbon percentage will be very low, then it is almost impossible to do the hardening. Means to improve the hardness of low carbon steel is almost impossible process here. In some kind of steels on the higher range you can do that, but whichever hardening depth you are getting, it will be very low. Okay, in short you can say that this is the low carbon steel can be termed as non-hardening steels. And the next is already that I have explained, that fourth property, you can do the fabrication work very easily or other cold working operations very easily. Okay, as simply how to remember the properties: whenever percentage of the carbon is low, that steel will be soft, malleable, ductile in nature. As it is soft, malleable and ductile in nature, you can do machining very easily, welding very easily, then forming processes, different forming processes very easily. And as carbon percentage is lesser, it is not possible to do the hardening of that kind of the steels. So in this way it is very easy to remember the properties. Then after writing the properties, you have to write some applications. Okay, for that low carbon steels, some applications are presented in the next slides. Okay, now this low carbon steels. First, I will tell you very common examples of the low carbon steel. Please see the application number 3, third application. I will first explain that because it is having very wide range. Whichever structural steels are there, whichever means the steels which are used in the structures, you can say that the different kinds of the beams, different used for the construction, beams, bars, then grills, different angles are there, different channels we are using in the construction, building construction. That steels are structural steels, or in other word you can say that that steels are the mild steels. And here I have mentioned the carbon percentage also. The steels which are having carbon percentage in the range 0.15 to 0.3%. Okay, these are the structural steels. Structural steels, and these steels are also known as the mild steels. Okay, for and how to, depending on the name itself, the structural steels means these are used in the various applications uh, in the building construction. You can say that different types of the building bars used, then different grills which are using for the windows, then different beams, different angles, then different channels which we are using for the supporting the structure. That all are made up from this mild steel, which is containing the carbon within the range of 0.15 to 0.3%. So this is the very good application, and it will be very easy to remember you or you can recall it very easily. Means these all structural steels, which are also known as mild steels, are nothing but the type of a low carbon steel only. Then go for the first application. Now here in the first application I have mentioned that different, you can say that whichever uh, different tubes which are manufactured, that steel tubes are there which we are using in the bicycle or different automobiles, or different automobile vehicles. It may be a four-wheeler. That tubes made up of the steel that is made up of low carbon steels. Then whichever fans you are using in your home or in your offices, that fans blades, that fan blades are made up of the low carbon steels only. Then different automobile components, like different automobile vehicle components, like different gears are there, different valves are there, then camshaft, crankshaft, connecting rods, all these are made up of the low carbon steels. Okay, all these are made up of the low carbon steels. Then the railway axles, these are also made up of the low carbon steels only. Okay, so these are the few applications. Now how to remember it? I have told you that structural steels, whichever structural components you are using in the building or in the construction, that are the all low carbon steel, which come under the category of the mild steel. And then the in the automobile sector, different tubes are made, which we are using in the bicycles, automobiles, and then whichever fan we are using in our home, that fan blades, then different automobile vehicle components, like you are saying that crankshaft, connecting rods, then different types of the gears, all these are manufactured with the low carbon steels. Then another components which are manufactured are different wires which we are using wires, then rivets, screws, different welding rods, and then the boiler plates, boiler tubes. All these are made up of the low carbon steels only. So if you are able to mention some 5 to 6 components, that will be sufficient. This is the explanation for the low carbon steel. First you have to write the percentage of the carbon, that is on which basis you are doing the classification. Then its properties, some general properties you have to write, and after that you have to mention some applications. Then I will move towards the next type, that is the medium carbon steel. Now this medium carbon steels, it is the type of the plain carbon steel, and it is containing the carbon percentage within the range 0.3 to 0.6%, and it will be termed as medium carbon steel. Now, it is very easy to determine the properties. It will be having in bit properties in between to the low carbon steel and high carbon steel. Okay, means you can say that it is having medium hardness. It is having medium hardness. Then it is not so ductile or not so malleable. Means it will be having the properties in between to the low carbon steel and high carbon steels. Okay, but as carbon percentage has increased here, it is slightly difficult to do the welding and machining. You can do that operations, but it will you have to do some improvements in that machining, or you have to use some higher specifications machinery here, or it will require some time. That will be the properties related to the what you can say, that machining or welding processes. You can do that, but not as easily as compared to the low carbon steels. Then again here, all the whichever machinery components are there, machinery components or different machinery parts are there, all that almost all parts are manufactured by using the medium carbon steels. That's why these medium carbon steels are termed as the machinery steels. Now related to the depth of hardening here, here in low carbon steel you were not able to do the hardening of that kind of the steels, but here you can do the hardening, and you can achieve some depth of the hardening here also. That's why it is termed as the shallow hardening steels. But you cannot do the hardening with the better effect like the high carbon steels. That's why it is termed as the shallow hardening. Shallow, or you can say that medium hardening effect can be achieved here. And we will move towards the applications. Now here the major applications here for the medium carbon steel, you can, it is used, medium carbon steel is used for the manufacturing of the railway rails, whichever railway rails, or you can say that whichever tracks are there on which that railway is running, that tracks all that are made up from the medium carbon steels. Then whichever tires are there, you can, if you observe carefully, some steel made tires are there in the railways. That tires are made up of the medium carbon steel. Then different types of the bolts, then different kind of the axles which are used in the different vehicles, all these are made up of the medium carbon steel. Then as in the first slide I have mentioned that the different tubes which we are using in the bicycles and other vehicles, that are manufactured from the low carbon steel. Now in the medium carbon steel, it is very easy to remember that. First try to understand that tube is made from the low carbon steel, whichever bicycle tube is there, that steel tube, that round portion is made from the low carbon steel. And whichever spokes are there inside that tube, that spokes are made up of the medium carbon steels. Okay, one application, consider just that bicycle. In that bicycle, that tube is made up from low carbon steel. Then whichever spokes are present inside that tube, that spokes are made up from the medium carbon steel. Okay, Then different kinds of these are some common applications for medium carbon steel and high carbon steels. Okay, different kinds of the springs, hammers, rods, depending on the strength required. We can made it from either medium carbon steel, or you can also go for the high carbon steel if your requirement is if you needed very high strength, then you can go for the high carbon steel for manufacturing of the hammers, different kinds of these springs. Then, and if you require some little bit lower strength, then you can also use the medium carbon steels here. Okay, these medium carbon steels are used for manufacturing. See the third point, different types of the springs, wires, then wheel spokes, that bicycles wheel spokes are there, and different kinds of the hammers. Then whichever rotors are there available for that, turbine rotors are there that are manufactured from the medium carbon steel only. Then crank pins and cylinder liners, which are present in the different vehicles, that are also manufactured with the help of this medium carbon steel only. Okay, so this is the medium carbon steel. Just try to understand the properties and try to remember few applications of that. Depending on the properties or nature, you can easily remember the names of that components which are manufactured from the different steels. Okay, after this, the third type is high carbon steel. Now it is the type of the plain carbon steel, and it is manufactured. Sorry, first I will explain its properties. Mm, Plain carbon steels which are having carbon percentage from 0.6 to 2%, that will be termed as high carbon steel. Then, as percentage of carbon is very high here, you can clearly understand that it will be having very high hardness. Then its strength will be also more, and sometimes when uh, percentage of carbon is very high, it can also behave like a brittle material. Okay, then as its hardness is improved, and as carbon percentage is very high, it will provide you very good wear resistance, corrosion resistance, then abrasion resistance is very good. Then, as percentage of carbon is more here, these high carbon steels are very difficult for doing the machining or for doing the welding of that component. It is very difficult process. Okay, so these are some general properties. Then, related to the depth of hardening, doing the hardening process of high carbon steel, it is very easy, and you can be able to attain very high depth of hardening here. And that's why it is termed as the deep hardening steels. Okay, just try to remember that this hardening is nothing but we are improving the hardness of that particular kind of the steel, doing the heat treatment process. How the actual process is conducted, and that part is in the second or third chapter of your syllabus. There we are having that detailed procedure. Just try to understand that whenever carbon percentage is low, then it is difficult to do the hardening, and as carbon percentage increases, you can do the hardening process easily. Depending on that, these uh, plain carbon steels, that is low carbon, medium carbon, and high carbon steels, are termed as, that low carbon steel will be termed as non-hardening steel. In medium carbon steel, we can do the hardening with medium amount, or depth of hardening will be smaller, depth of hardening can be achieved. That's why it is termed as shallow hardening steels. And in high carbon steel, we will be able to attain the desired depth of hardening. That's why it is termed as the deep hardening steels. Then these steels, that is high carbon steels, are used for manufacturing of the different tools which we are going to use for doing the cutting or different machining operations. Why we are using that? Because it is having very high strength and high hardness, and it is having better wear resistance and corrosion resistance. That's why we are using these high carbon steels for manufacturing of the tools which we are using for doing the different cutting operations and different machining operation. That's why these steels are termed as the tool steels. Okay, Now, so these are now here in the next slide. I have highlighted here some important applications. Now, high carbon steels. Now, to understand the applications of the high carbon steel, just try to visualize your workshop. I think you have visited the workshop lots of times to perform your different jobs which have assigned to you. Just try to picturize your workshop in front of you and different instruments available in that workshop. Almost all instruments available in that workshop already you have used that are made from high carbon steel. Okay, it is very easy to remember this. Just visualize the all the equipments available in the workshop which you have visited in your second year, and that different types of the chisels are there. Chisels, then wise jaws, then the shear blades, different types of the drills which you have used, then different types of the reamers. Then from your home appliances, different kinds of the knives you are using, or different types of the razor blades you are using for your home applications, that are all made from the high carbon steel only. Then different kinds of the hammers are there, then different kinds of the cutters, mandrels, files, all these, then punches are there. All these are manufactured from the high carbon steel only. And see the next second point here, that different types of the dyes. Okay, the dyes I will combinely second and third point I will take combinedly. Different types of the forging dyes are there, and different types of the wire drawing dyes are there. Okay, that are made from the high carbon steels only. And these punches, hammers, and springs, and clutch discs, I have discussed that. Punches, hammers, springs, these all are made from the high carbon steel only. Then go for the third point. Then different types of the leaf springs are used. Okay, leaf springs, I think these are used in the railways also. If you have seen the railways, whichever coach, railway coach is there, at the bottom of that, the leaf spring is provided. Okay, leaf spring is there. Then different musical wires are there. Then in the ball bearing, whichever balls are there, that balls are also manufactured with the help of this high carbon steel only. Then mandrels, cutters, files, already this I have discussed with you. All these, just simply you can make a list whichever different accessories or instruments available in the workshops, all that are manufactured from high carbon steels. Then different dyes, that is forging dyes, wire drawing dyes, that all are made from this high carbon steel only. So these are the applications for the high carbon steel. Okay, so in this way we have completed this part. Plain carbon steels. This plain carbon steel, what is the meaning of the plain carbon steel? Then after that, how these plain carbon steels are classified depending on the percentage of the carbon. Then what are the different, one by one we have discussed. After that, it is what is the meaning of low carbon steel, what are its properties, what are its applications. Then in the same way we have discussed the medium carbon steel, what is the meaning of medium carbon steel, then its properties and its applications. And lastly we have now just discussed the high carbon steel, what are its properties and its applications. Okay, you have to go with this sequence. In the first point you have to write what is the meaning of that low carbon. Suppose low carbon steel, in what amount of carbon is present in that steel, then depending on that carbon you can decide its properties. And after deciding the properties you can write its applications. Okay, so this is the discussion related to the plain carbon steel. If you are having any query, you can ask me, or if you are clear, then I will move towards the next classification. Some few classifications are there of the steels. depending on the different parameters that I will explain within 5 to 10 minutes. Can I move towards next slide?
Yes, sir.
Okay. Prajwal is there. Prajwal.
Yes, sir.
Okay. I'll ask any other person. Chaitanya Wadekar. Chaitanya. Are you there?
Yes, sir.
Okay. Okay. All points are clear. Can I move forward? Can I move towards next slide? Wadekar.
Yes, sir.
Okay, okay. Fine, fine. Now, here I have highlighted some other basis of the classification of the this is the classification of the steels only. Now, already this classification already we have discussed during that different types of the plain carbon steels. This classification is done on the basis of the depth of the hardening. Here, the steels are classified in the three types: non-hardening steels, shallow hardening steels, and deep hardening steels, depending on the their ability or in how much way or in how much quantity you can achieve the depth of hardening, or in how much quantity or in how you are going to improve the hardenability of that particular kind of steel. Depending on that, these are classified as non-hardening, shallow hardening, and deep hardening steels. Now, non-hardening steels means it is almost impossible, or it is very difficult to do the hardening of that kind of steels. Means here, already we have discussed this depth of hardening is based, it depends on the percentage of carbon and amount of the alloying elements present. Okay. If different alloying elements are present and carbon is also there, then their depth of hardening will be very high. You will be able to achieve very high depth of hardening. Then, as in the low carbon steel, we have seen that uh, other alloying elements are completely absent and carbon is also present in the low amount. That's why that will be termed as non-hardening steel. Means it is very difficult to do the hardening of that kind of steels. Then the medium carbon steels are termed as shallow hardening steels, because carbon percentage is in medium amount and other alloying elements are absent here. That's why it is termed as the shallow hardening steel. Means we can achieve the little bit depth, we can do the depth of hardening, but higher depth cannot be achieved here. That's why it is shallow hardening steels. And in deep hardening steels, here high percentage of carbon will be present in this kind of steels, and in some amount of alloying elements may be there in some other kinds of the steels other than plain carbon steel. Okay. For high carbon steel, as percentage of carbon is high, you can do their hardening with the higher depths of hardening. And for some alloy steels also come under this category in the deep hardening steels. Okay. Some alloy steels also come under the category of the shallow hardening steels. Means medium carbon steels with addition of some alloying steels, that also will considered in the shallow hardening steels only. Okay. So these are the three different types of the steels depending on the depth of the hardening. Then the next basis for the classification of the steels is grain coarsening effect or grain coarsening characteristics. Now, before going for actual discussion of the type of the steels, first you should understand that what is the grain coarsening effect or grain coarsening characteristics. Okay, I will tell you that whenever you are doing, suppose you have taken the steel and that steel is at the room temperature, then just you have to measure the particle size in that particular kind of steel. That you can do by taking its microstructure, and some softwares are available. With the help of that, you can check their grain size. Okay, grain size can be checked for different kinds of materials. Then at a room temperature you have to take the note of that grain size. And when now start the heating, and when you are starting doing the heating process, as temperature is raising, continuously temperature is raising, then there will be changes in the grain size. And when that grain size increases in large amount, that effect will be termed as the grain coarsening. When grain size of the particular material increases along, when we are using the increasing the temperature, then that effect is termed as the grain coarsening. Grain size of that particular material will increase when we are increasing the temperature. That effect is termed as grain coarsening. Okay, it's particle, in short, particle size increases when we provide the heat to that particular material. Now, how with help of this concept, how the classification is done: coarse grained steels and fine grained steels. Now, what are the coarse grained steels? Suppose one steel we have taken and we have provided gradual heating. Then as heating increases or temperature increases, its grain size will start gradually increasing. Okay, as we are increasing the temperature, then along with temperature, grain size will also increase. Okay, that will be termed as coarse grained steels. Means at very, whenever you are starting the heating, suppose you have heated up to 200 degrees Celsius, then its size will change. Then at 300 degrees Celsius, again grain size will increase. At 400 degrees Celsius, again grain size will increase. That will be termed as coarse grain steels. Means small increase in temperature will also change the grain size of that particular steels. That will be termed as coarse grain steels. Then the next type is the fine grain steels. But what happens in the fine grain steel? Suppose you have increased temperature up to 200 degrees Celsius, then its grain size will be constant. At 300, again grain size will be constant. At 400, again grain size will be constant. In this way, when you reached up to the higher temperature ranges at 900 degrees Celsius or above 1000 degrees Celsius, then grain size will start changing. That type of steel will be termed as fine grained steels. Means the steels in which grain size will remain constant up to a higher range of the temperatures, and at higher temperatures it starts changing. That will be termed as fine grain steels. Okay, and in coarse grain steels, at smaller or lower temperatures also, the grain size will start changing its size. Means it increases. That will be termed as coarse grained steels. Okay, are you clear with this coarse grained and fine grained steels?
Yes, sir.
Okay, then I will move towards next classification. Okay, next is the classification based on the now this classification based on the deoxidation process that I will explain at the last. First, I will explain, finish the others, because that are the remaining are very simple and it will take a little bit time. Just see the second classification on the basis of method of manufacturing. While manufacturing, this is the simple classification, and this classification is done on the basis of which kind of furnace is used for manufacturing of that particular steel. And these are the different types of the steels: basic open hearth, electric furnace, basic oxygen process, acid open hearth, and acid base simmer. Okay, just this is the these are the types of the steels depending on which furnace you are using. or which different processes are applied during that manufacturing of the steel. Okay, just here these are different types of the furnaces, and with the help of this furnace, if that steel is manufactured, then that steel will be called by the name of that furnace. Then the next classification is on the basis of the form and use. Okay, here almost nine types are there: boiler steels, case hardening steels, corrosion and heat resistant steel, deep hardening steels, free cutting steels, electrical steels, machinery steels, structural steels, and tool steels. Now, all these types or this classification is done on the basis of that particular steel is used for that manufacturing of that particular application or doing that particular application. I will explain it in short. For manufacturing of different boiler plates, a particular kind of steel is used: boiler plates, boiler tubes. A particular kind of steel, that is low carbon steel containing carbon percentage below 0.25%, that will be termed as boiler steel. Then for doing the case hardening, suppose we are just doing the hardening of the surface. Suppose gear is there, then we want to do the improve the hardness of the surface, then just hardening of the surface is done. The steel which is used for that application, it will be termed as case hardening steel, like this. Then corrosion and heat resistant steel, the steels which are used for the manufacturing of the component which are having very high corrosion resistance, and that can be used at the higher temperature range applications, that are termed as corrosion and heat resistant steels. Then drip drawing steels means the steels which are used for drawing them into the different steel wires, that particular steel is deep drawing steels. Then free cutting steels or machining steels means here we are going to manufacture different bolts, screws, then rivets, that will be termed as the free cutting steels. Okay, then the next is the machinery steels, or sorry, electrical steels. Electrical steels are these steels which are used in the different electrical applications or manufacturing of the different electrical components. And machinery steels, already I have explained this. Machinery steels are nothing but your medium carbon steels. Structural steels are nothing but your low carbon steels. Tool steels are nothing but your high carbon steels. Then the next classification is on the basis of the alloying elements. Whenever percentage of the alloying element is within the range of suppose below 5%, then it is low alloy steels. When the percentage of alloying element is 5 to 12% or 10%, that will be medium alloy steel. And when the percentage of alloying element is above that 10-12%, then it will be termed as high alloy steel. Okay, so this is the simple classification. Now just one classification is remaining, that is I will come to this point, that is classification on the basis of the de- deoxidation process here. Now whenever first I will explain this, it will take 5 minutes only. For rimmed steels, killed steels, and semi killed steels or balanced steels, now, whenever we are doing the manufacturing of the steels, first we are heating it to the into the molten form. Okay, whenever we are doing the manufacturing of the steels, we are heating it to the molten form, and suppose here, we are doing the different process. Now, suppose during this process, what will happen in the liquid or in the molten form of that particular material, we are here giving the different shapes. Suppose you are manufacturing the steel in the form of plate or in the form of rod. To give the different shapes, first we are giving heating that and transforming it to the molten form or liquid form. Then during this liquid form, what will happen, the surroundings oxygen, whichever oxygen or different gases present in the surrounding, that gases and oxygen will get dissolved in that liquid or molten steel. Okay, and as we know that in the liquid form, more gases and oxygen will get dissolved as compared to the solid form. And when whenever that steel is in the molten form, large amount of the oxygen and other gases will get dissolved in that molten steel. And when we are doing the cooling or during the solidification process, that oxygen or other gases will get trapped during the solidification. And in that steel at the end you will get some blowholes. Okay, you will get some blowholes due to the entrapping of the oxygen or the gases during the solidification process. Okay, some blowholes will be present. Now, to avoid these blowholes, different processes we are using. Depending on the different processes used, these steels are classified as rimmed steels, killed steels, and semi-killed steels. Now, to avoid this entrapment or to avoid the formation of these blowholes, we are making or manufacturing the steel plates having very small thickness. Okay, very small thickness to avoid the formation of the blowholes. If that formed steel is having, suppose we have formed steel with having very thin thickness or smaller thickness, then automatically during solidification blowholes will not get formation of blowholes will get avoided, or blowholes will be present in the smaller quantity. That will be termed as the rimmed steels. Blowholes will be there, but we are trying to make that plate with very smaller thickness. Due to that, it will be termed as the rimmed steels. Plate having very small thickness, it will be having termed as the rimmed steels. Due to the smaller thickness, what will happen, that blowholes will get means you can say that in simple words, it will get punctured, means that gas will get released, it does not get trapped in that plates. That type of steels will be termed as rimmed steels. Now, in the killed steel, what will happen here, we are not going for making the thin plate steels. Here what we are doing, we are adding some deoxidizing agents like aluminum, manganese, or silicon. With the help of that ferromanganese or ferrosilicon compounds are there, that we are adding. And when we are adding that kind of deoxidizing agent, they will, what they will do, they will react with the whichever oxygen or gas is present, and at the end they will not get trapped, or formation of blowholes will get avoided. In this way we are killing whichever blowholes are there, that we are going to kill by addition of some oxidizing agent. Okay, that's why it is termed as the killed steers. Here we have killed that whichever blowholes are there, here we are cooling by adding the deoxidizing agents like aluminum, manganese, silicon, with the help of their respective materials like ferrosilicon, ferromanganese. Okay, and same third type is semi-killed or balanced steel. It is just the combination of rimmed steels and killed steels. Okay, so these are the three types depending on the basis of the deoxidation: rimmed steels, killed steels, and semi-killed steels or balanced steels. Okay, so in this lecture, in this way, we have completed the classification of the plain carbon steels. In that, we have learned low carbon steel, medium carbon steel, and high carbon steel. After that, we have discussed the classification of the steel on the basis of depth of hardening, in classification of the steels on the basis of grain coarsening characteristics. Then we have seen the classification of steels on the basis of deoxidation, then on the basis of methods of manufacturing. In that, this classification is done on the basis of which furnace is used during the manufacturing of that particular steels. And next classification is done on the basis of their different forms or their direct applications. Depending on that, names is given. And the last classification is on the basis of the different alloying elements. means amount, or you can say the percentage of the alloying elements present in the steel. Okay. So in this way, in this lecture, I'm about to finish the lecture. If all points are clear, I will conclude the session. If you are having any query, you can ask me. Or can I conclude the lecture? Please give me reply. Prajwal. Prajwal
Sir,
is
you can
there?
conclude.
Okay, all points are clear, na? If you are having any doubt, I will repeat some part in the next lecture. Please mention that in the chat box. I will repeat that part. If you are having any query related to any point. Mangesh Misal. Can I conclude the lecture, Mangesh? Mangesh, can I conclude?
Yes, sir. Yes.
Okay, 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 okay. Thank you all. I will stop here. Thank you.